Are we ready?
As ready as we're ever going to be.
Programming languages. You love them, you hate them, you just can't justify a Silicon Valley salary without them. And we love talking about them. I'm Just here. I go by Jas. This is Mike.
Hello, everybody.
This is a podcast series where we talk about programming languages and what's next.
What's our topic for today, Jess?
I was thinking about strings. I've been thinking about strings for a bit, and I thought that we could pick each other's brains about strings.
Yeah, I guess as far as programming languages go, there's three kinds of languages. There's untyped languages, there's strongly typed languages, and there's stringly typed languages.
I was wondering how you were going to tie this to strings. Sure. Tell me about the first two quickly, and then we're going to dive into what a stringly typed language is, because I definitely have no idea what you mean by this.
Yeah, so untyped, I guess, in an untyped is not really a fair representation. In Python, you have types. You don't have to say what the types are, but every value has a type, and you can say, is this thing of this type? And there's also kind of these conceptual types. If it quacks like a duck, then it is of some duck type, even if you've never declared duck as a type.
Okay.
And there's no, kind of way you could say, is this thing a duck? And so, but in untyped languages, the compiler isn't involved. There's no one time at which you check that all of the typing relationships make sense. There's no kind of time at which you're deciding this is coherent. The types are coherent. Inputs and outputs kind of follow agreed upon conventions.
Okay.
Whereas in a strongly typed language, you are checking that it's strong because sometime before the program finishes running, you've checked the types. And that may actually happen at multiple times, right? In Java, it happens once when you compile it, but then also when you load classes, there's an extra layer of type checking. The bytecode verifier is going through and saying, kind of, are these values allowed to fit in this box with this type? And so before, and in Java, classes can continue loading throughout the program, but before a class actually gets used by part of the programming, it's undergone both those stages of type checking, the compilation and the bytecode verification.
I see. So that's typed and untyped.
Yes, types and strongly typed.
I see. And what is a stringly typed language then?
Well, and so
which I think this is something you're just making up.
No, I think it goes back to some famous Stack Overflow post. Stringly typed code, which is somebody contrasting strongly typed with the idea that, hey, you can represent almost any value as a string.
Right.
Like in part of the Y2K problem, where we had to migrate huge amounts of software written before year 2000 and that used dates in a particular way. How did it represent dates? Did it represent them as 4-byte integers? No, we would have actually had more room. No, it represented them as strings,
Right.
2-digit year, 2-digit month, 2-digit day of the month. And the reason why that representation was popular was partly because you can just shove it in a database, and then you can select from the database, and you see things that look like the kinds of dates you're used to, right?
But don't you end up in that case like searching for dates using, like, how do you do like a comparison between two dates if it's represented as a string? Like, isn't this making like your life harder?
No, if you don't care about if you don't care about negative years, and you don't when your year is like the last 2 digits and you're assuming 19 in the front of them. So like you're representing the year 1980 as 80, right? So if you
Like
have year, month, day,
right, but
then
if I represented this as a string, like how do I do, like if I do a sort of like databases will provide me with a string sort,
yeah,
and string sort is different from the date representation sort.
yeah. And so, yeah, I mean, when you select something from a database, you can say how you want it sorted, right?
Right.
Yeah. And you can do order by clause, and I think then you can, but yeah, if you represent things as year, month, day,
Right.
then you actually, it kind of falls out of that. But I think the real reason why people represented dates as strings instead of number of milliseconds or seconds since an epoch, right? Was because the representation that you see when you print something out is much closer to your mental model, right?
I
And
see.
so, like, I worked on Google Calendar, and one of the things, like, we definitely did not represent dates using strings.
Strings. Okay, good.
But one of the things that I like, and we had a Java backend, and in Java, the Java util calendar, which was this was before Java got good date representations.
Mm-hmm.
The convention was that a month is a number between 0 and 11 because
Right.
because you zero index. That's just what we do as programmers. And this caused so much confusion for me that eventually, like, when we had to turn something into a from the representation we had internally, which was like bits packed, when we had to turn something into the month, we were just like, no, we're going to one index the month, because just that simple change makes debugging so much more straightforward. You just need to think, you want the thing that you see when you debug to match your mental model. And
Right.
we carry around a mental model of dates that we learned in elementary school, right? And strings are hugely useful, like, because they match the mental model when you're kind of casually developing and debugging, right?
Right.
But where they fall short is that strings are also hugely weird.
Yes.
And
I mean,
yeah,
they're weird because there's a bunch of biases and there's a bunch of biases that you bring to the problem, right? Like, how a string is represented. I mean, we have like a little endian and a big endian representation of dates. I'm worried that we're fixated on dates because dates themselves have a whole bunch of
but dates are also a thing everybody knows,
right.
right? Yeah.
Yeah, exactly. But like, one of the biggest challenges that I had moving to the US was that dates in the US are neither big endian nor little endian, both
Yeah.
of which are justifiable. They're sort of this mixed endian, and there's no sensible way to sort dates. But that's how they are represented if they are represented as strings. And the advantage of representing, if I pull out a little bit, like the fact that the representation as a string is the data structure that I am storing ends up being hugely complicated, right? Like, yes, I've simplified debugging because printing out the internal structure is exactly what I will understand.
Yeah.
But like now, I have to make sure that everybody knows that, like, 1177 means
Yeah.
January. Well, actually, 1277 means January the
And I
2nd.
think you
Or
you you hit on the big problem there,
uh-huh.
like the other person, which is
Right,
now there's two people involved.
right,
And and when you have like complex, carefully crafted data structures, that allows many people to work on the same problem, right? But and so strings, while they're you can get a project to a certain stage. You have a mental model. That mental model very closely maps how you interpret parts of a string.
Right.
But as soon as you get somebody else involved, now like, hey, does the day of the month have to have 2 digits, or can it have one? What
Right.
happens when one person is producing them with variable numbers digits and everybody else is assuming that they have 2? These mismatches occur, and so rich, carefully crafted types are points of coordination between people, so we don't each of us have to know what everybody else is thinking.
The part that bothers me here is like everything that you said makes sense to me, right? Like it is of course we should do this way. Of course we should do this. But like I know I myself have done this thing where like partway through like coding up something, I'm like, I'm just going to serialize this into a string, and then I'm just going to pass the string representation around. Like, what do you think it is? And I don't know whether you've had that experience, but like, if you have, like,
I mean, I've sat down and I'm like, I need to deal with URLs. Well, a URL is a string that starts with, and yes, it is a string in some sense, but it's also this incredibly richly structured, for programming language entirely in its own right.
Right. Exactly. There was so I tweeted about this a couple of days ago, and one of the responses that I got, which was definitely a joking response, but like which really resonated with me, is, "Hey man, every string deserves a parser." And I was like, "Wow, that actually is. This is insanity." But it was like it actually resonated with me, because essentially what I'm doing in those moments is passing around packets of bits, which I
Passing
know
with
at
two
some
S's
point.
or with an RS?
Wait, say that again.
Passing or parsing?
Passing.
Yeah. All right.
I'm passing and then eventually parsing. This set of bits, because it's so convenient to pack a URL together and just pass it around.
Yeah.
I think that you're hitting on the right point, because whenever I print it out, it prints out in a way that makes sense. And if I take insanity bits suggestion to its logical conclusion, it is that every string should have a parse, or every data structure should have a toString. And like the latter seems like that's many languages have that idea.
Yeah. Like people need to convert things to diagnostic forms that they can then understand, right? And so
correct.
Like Java's toString feeds into how things show up in the debugger, like the debugger shows you, oh, your local variable X has this value, and that involves like calling toString on some Java object, right?
Right. I think I'm going to end up adding a link to the podcast at some point, but there's I think her name is Katie, who ends up taking this not just to strings but to like visual representations of states of your program, right? Like her like she advocates for hey, anytime you have a state in your program, you want not just a toString, but maybe a like 2 dot file or 2.
And I think some languages like Smalltalk and Racket, languages that grew up alongside a very specific debugger. People are like, hey, everybody in the community is going to share the same debugger, and it'll be great. They do nice things like this, like your object graph, you can kind of click it and visually see it.
I mean, I think that we, like you and I right now, are circling around, hey, strings are just a way of doing debugging. Like at heart, we didn't need them.
Not just a way of doing debugging, but a representation that gets you very close to, anyway.
Model, right? Yeah, no, yeah. I think that we're, so that's certainly one. I don't think that explains all of the reasons why people reach out for strings when they do, right? Like, there are languages that don't have strings as a first-class object, And we suffer
Can you think of an example?
C does not
Yeah,
have
yeah,
a
okay, fair. Yeah, yeah.
right, like
yeah, C strings are not self-contained unless you follow the null terminating convention. And
right.
most programs that deal with C strings, most large C programs somewhere at some point in time, things that should be strings are not actually following the null terminating convention until later they add it back. And so
right.
you can't assume you can't assume if you're debugging a C program that you're actually going to find the null terminator until yeah.
Yeah, and I mean, like the fact that we keep reinventing strings, like sometimes I take a very strong position that a programming language should not have a plain old string representation. I think that this is a mistake. I know that is a
strings are only meaningful with more context, and
exactly.
you want that context to be represented somewhere in the program, either in the value or in the type system. I want it to be
represented explicitly. Exactly.
Yeah.
Exactly.
Yeah. All
right. But I worry because
so let me give you a concrete example, and maybe we can get into where does the okay, so I've started and I've got strings and they're great because they match my mental model. Where does that break down? And I think the answer is many places, but one for example, like the URL, right?
Right.
If I have a slash and then I put out a path component and a slash, that's a particular kind of relative URL, right? But yes. URL parsing rules say that if something starts with double slash, then the thing that follows that double slash, it's not a path component. It's actually the authority, basically host name, port, and some other stuff, right? And so, like if I create a URL by saying the string slash plus x plus slash foo.txt, right?
Right.
Is that a path relative URL? Well, it matters about the value of x, right?
Right.
And so, almost, like if it's one person working on a project, like they're probably not going to be throwing weird values of x in there. Things will seem to work, but where, having a URL builder data type or a way of composing URLs that is that embeds the knowledge that the first path component cannot start with slash.
Right.
If you do that, you're going to have to do slash dot slash or something. That knowledge has to be somewhere, and it shouldn't be everywhere you concatenate strings together to produce a URL. You want to embed that knowledge about corner cases related to the data type that you're producing, and strings are just not good. Simple things like string concatenation don't work in defensively written software maintained by many people, because you can't consolidate that knowledge about corner cases in one place.
The template strings in JavaScript feel underutilized to me, because like people call them template strings, and the implication is they're strings, but they're not strings, right? Like the return,
weren't they called string templates for a while before they were called template strings?
They were,
so I think
and it's
that
possible that
switch
they
in
may
nomenclature,
still be.
I think,
But they give us a great place to stand to make it so that when I write it out, it looks like a string, and so like my mental model is correct.
Somebody reading like here's a URL backtick, blah 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 backtick, can see, oh, I know what the intent is, even if I don't understand the exact semantics of URL. I know what the author was getting at. And then,
but at the moment, like most libraries that return, URL backtick something will still return a string, like an actual string. Like the underlying data structure is still a string. But like at least that gives us a place to start to say like, oh, we're separating what the programmer's mental model is from what the underlying structure has to be. Unfortunately, in the JavaScript case, string concatenation is something that you really want, right? Like,
Yeah.
I do want it to be the case that URL backtick, whatever,
Yeah.
HTTP colon plus, URL colon some relative URL like works. And
Yeah.
that's not going to work here,
And I
right?
think, you and I both worked in the security engineering world for a long time. And one of my, I spent some time doing weird things with type systems where the type system was was representing like the state of a partially built string on an output buffer so that you could get and I wrote JavaScript tag template libraries that are up on npm for multiple variants of SQL and bash, so that you could safely craft an output to send to the shell. And I think the lit HTML people have done it for HTML. And so it's definitely possible to write these, but I think the problem, and I never did a good job advertising these. but I mean it's definitely
you get the chance to plug it. You get the chance to plug it right now.
Okay, so our hello listener, I'm assuming there's one of you out there. If you're looking for a JavaScript tag template library that will safely and robustly produce strings of SQL or bash or HTML, kind of, what I think what the approach that you're talking about, gets right is the template, the part of this, the string parts of the template tag say, these are the parts written by the author. Take these as trusted. You trust the author, you trust those parts. The parts between the $ curly brackets, the values that are being substituted in, we need to interpret those values so that they fit, and we can come up with this kind of model of safety. So for HTML, we'll escape things appropriately. For SQL, if you interpolate something, you probably meant it to be a value and not, some part of the not keywords in the query language. And for bash, you probably meant to pass this $ curly brackets X as a string on the command line. You didn't mean it to,
like expand out to
expand to a subshell.
Right.
And so the not only is it readable, it's got all the benefits of readability. Like I'm creating a string-like thing from string parts, trusted string parts, and untrusted values. But like you said, we stand at a place. The URL tag embeds knowledge about how to safely compose URLs. And so you kind of get the best of both worlds, like this concise, relatable syntax, but also, the knowledge about corner cases is embedded in a shared library.
Do you think that template literals are the right way to do this capturing? Do you think that there's other structures that might be better at doing this?
I mean, it generally, like if we were sitting down to design from scratch, the web platforms from scratch, and we're like, okay, we need a way to design, to embed HTML, and because a lot of our programs involve manipulating HTML, and we need a way to produce CSS because a lot of our programs, and similarly for URLs and the other micro languages. I think we might end up with something, we might come up with DSLs, domain specific languages. So, again, we want the ways that we produce HTML to look like HTML so that our code is readable, but we also want it to be safe and handle the corner cases. And I think, JSX gets this right, but it's very specifically for XML-like things. So, we could have, like, had we known about web programming now, what we did in the 90s. JavaScript might have JavaScript X-like features. It might have ways to embed things like CSS.
Didn't we have what was it called? ESX? No, ESX.
E4X.
E4X.
ECMAScript for XML, and that was yeah. And I think I think Facebook, I think, took the best parts of E4X. I don't know whether they intentionally, I don't know how much they knew about E4X, but I think they got the best parts
the essence of it.
But I think E4X failed partly because XML is a bigger problem. And it was a Firefox only thing, and Microsoft was not at the time. Microsoft was not, there wasn't the, TC39 was not coordinating how, Microsoft and was it Netscape or Mozilla? I forget. We're not collaborating well, and a lot of that is Microsoft's leadership, not necessarily the IE16. But yeah, I think E4X was stillborn to some degree because of the nature of competition at the time.
I mean, I also get very excited about parsing confusion, particularly once you have a language and then you're trying to evolve it, you're trying to grow the syntax. E4X had all kinds of very exciting, I was going to say character flaws, but because trying to retrofit a fairly extensive extension to a language was very challenging. I haven't looked at JSX enough to know how they avoided those particular problems.
I think with some judicious hand waving. But I think to your point, do you need anything more than template strings? I think template strings give you a way to do DSLs, but I think the general problem is DSLs, and how do you have a DSL for HTML that embeds CSS? JSX doesn't do that, right? Like if you have a style attribute, it's still like, hey. I think there are some facilities where you can say style equals expression, and if it's this JavaScript object that kind of embeds color properties and so on, it kind of. But now you're saying, oh, we've got this affordance in the HTML producing DSL, which translates objects to CSS. But we can't really embed our CSS DSL in an appropriate place in our HTML DSL.
Right.
And so, the things are still awkward where language at the boundary where languages nest. And so I don't think we have a good example widely used in production of kind of these content generating systems understanding language nesting boundaries smoothly.
The language nesting is very interesting, right? Like, so sometimes I feel like it's the reduction to strings, like it's the serialization moment where this. I mean, nested embedding is not unnatural. I think happens all of the time.
And I think the dual to the thing that you brought up earlier, every string needs a parser. Every object that is going to that corresponds to a string, like if we're going to send content to the HTML parser or we're going to ship it across the network to a browser, like every object that leaves the system needs to have an unparser.
Yes.
And the language nesting problem is like we'd want to do that unparsing as late as possible.
Right.
And unparsers need to invoke unparsers in other languages, right?
Right, but like also unparsing has this weird context sensitivity because unparsing something requires me to know
should we say a little bit about what unparsing is, because it's honestly a horrible term that I hate very much, but it's the term used in the literature.
And accurately describes what. Yes, please tell me what, Mike, what is unparsing?
I was actually hoping that you were going to tell me what unparsing is. and our listener. So unparsing is just the reverse of parsing. You have an object that could have been parsed from a string
Right.
in a language, and you want to turn it back into a string in that language. And that's there's a lot more to it than that, because of course you might parse an object from a string, make changes to it, and then find, oh, there's no possible way I could turn this back into a
Right.
string in the language.
I find that particularly fascinating, right? Like,
Yeah.
like I mean, this is a weird example, but like if you parse a Java class, for
Yeah.
example, you can parse a Java class, Java bytecode into the Java, the language. And it's one of the nice properties of Java is that there's a sufficiently close mapping that in many cases you can do that. But there's all kinds of weird restrictions that the Java, the language, has, but the bytecode representation does not. So for example, try catches are always
Exceptions are erased.
right.
Sorry.
Like try catches are properly nested, right? You can't have
Oh, okay. Yes,
try on
because
something and then try on something else and then
yeah,
close out the first try and then close out the second try, right?
things
Like
that
everything.
are block-like in Java, like synchronized, correspond to
Right.
pairs of instructions, like lock and unlock instructions.
Exactly.
And the unlock has to appear inside a try finally, effectively, kind of, so it fits into the protected region stuff. And now, yeah, okay.
But
Sorry,
but but
I'm
but
babbling in
now
a way that
no,
I
that
think
makes
I'm probably
complete sense to
losing
me.
listeners. But yeah.
No, but like
Well, as long as
like
you're the only listener of this podcast, then we're solid.
Mike, this
Yeah.
is a conversation between you and I.
Okay.
But the nice thing about it is that no, I don't know whether it's a nice thing, right? Like they are representations of underlying objects that are just not serializable.
Yeah.
They're just not representable as a string.
Well, to take it back to HTML, which I think
Mm-hmm.
many people are familiar with. I can parse a div tag from HTML, right?
Right. Right.
And maybe I have, or sorry, maybe yeah, like I have a paragraph and it has a bold tag and an italics tag, right?
Right.
Like the word hello in bold and the word world in italics. And then I can programmatically, I can programmatically take the italics tag and stick it inside a plain text tag, right?
Yes. Yes.
And of course that's not going to be serializable, because HTML has this property that the first time you see a plain text tag, you
Right.
stop parsing normally
Yes.
and you switch to this mode where everything else is interpreted as if it were plain text. And this is because like somebody way back early in the history of browsers was like, yeah, I don't want to, like, I want
a
a
way
fancy
to
title,
represent.
but then I'm just going to dump like an email message in the rest of it, and I don't feel like going through and escaping it all. So just give me a plain text tag, and
yeah, plain text remains to this day
yeah,
my
but there's
favorite
many
HTML4
examples.
deprecated
Yeah,
tag. Yeah,
yeah,
no,
yeah.
you're
There's
right, right? Like
many other examples. It's not just plain text. Plain text is just one of these. Like if you look through the inner HTML algorithm in HTML spec, it's like, yeah, we can't do anything with this. And plain text is just one of many cases.
I mean, one of the beautiful things, and I don't know all of the corner cases, but there are many cases now where the DOM API will prevent you from adding a child in a place that it is not going to be able to serialize, right? Like,
Does it really?
yeah. And actually, I should know what part of the HTML5 spec says this. But in practice, if there are children that you can add, and there are children you cannot add because the type is wrong.
Okay, so this is like you can't put a T head inside of a TD or something, for example, without an intervening table kind of thing. I mean, there's these kinds of
I'm going out
containment
on a
rules,
limb. Yeah, exactly. But that kind of thing. I don't know whether this is true for tables, but
yeah.
that's the kind of thing that
Yeah.
because they know that when serialization time comes,
Yeah.
You won't be able to round trip this thing, right?
Yeah, and then there's always kind of contextual serialization problems. Like I can construct a DOM that has a no script element using JavaScript.
Right.
And
Yes.
I could probably serialize that out. It's definitely not going to have this. It might not have the same meaning, like depending on what I do in there, but because there's multiple modes in which it could be parsed, and trying to satisfy all of them is well, if it's doable, it's tough.
Mike, we're coming up to time. I'm going to make this a habit. This is it's a good thing, it's a bad thing, where I'm just going to throw a bunch of ideas at you related to today's topic, and you say if it's a good thing or a bad thing.
Okay,
this
so
is me putting.
Rule here is I can't go
this...
giving nuanced answers and like, well, I think that on the one hand, but on the other hand, I gotta. All right.
You're just gonna power through it. I'm not sure whether you can stop yourself from going into nuance, but that's the rule.
I am decisive.
Strings as an array of characters.
Bad thing. I think I think almost always what you want to do with strings is left to right parsing, sometimes right to left parsing, but you're parsing and you're considering things close to one another. Sometimes you want to go forward a little bit, look back, but it's not like arrays are for random access, and right. Arrays, kind of we usually think of them as contiguous chunks of same size memory, but in text, we don't have contiguous chunks. Like we have UTF-16 or UTF-32 or UTF-8, where one thing, a code point, an emoji, any kind of definition of character might take different amounts of space. And so, like if what you're not doing, if you don't need to do random access, why would you provide random access APIs like array APIs? Right. It's just an impedance mismatch, and I think it's there for history. People know the strings API, represent that way of interfacing. They know that interface, but it's not a good interface, and it hasn't been a good interface for
a long time.
Since UTF-8 basically.
Yeah. Since Unicode. This brings me to the second question. Unicode, good thing, bad thing?
Good thing, but I mean, it's a hard problem. I'm not going to bag on the Unicode people for not being perfect. They're wonderful, and yeah.
My favorite Twitter handle to follow is fake Unicode. I find that they have fantastic things to say. I think that they're the best kind of satire on strings. Length or null terminated representation? So Pascal or C.
I mean, so this is going back to, both of them assume the array representation, which I've already said I dislike. But yeah, yes. the null terminated, like, it's a mess. Like when you want to deal with like if you're writing an image codec, you're taking a GIF or and turning it into actual pixels that you can render. Then you want an array of bytes, but that's not a string. And if you're dealing with text, then like the array representation isn't a good one. I think like C, the C representation works for C, but C has C should be used for an increasingly small set of problems that you've got compatibility needs, or you're working in a number of small spaces like embedded systems or operating systems.
I think that's definitely a topic for another podcast. I think that we have all kinds of interesting things to say about C versus higher level language.
C is an important language in the history of computing, and it's still important if you need very precise control over what goes where in memory. Yeah. Not necessarily what instructions are executed.
Right. But like somewhere closer to the
But writing, there's no reason we should be writing text processing tools in C these days.
Right. Representing programs as strings.
I guess there's the alternative approaches are like block languages like Scratch, and and languages where you edit something that looks like code, but actually it's represented as an AST, and that the code view is presented to the user as a fiction, as a useful fiction, right?
Right.
This is not my field. I think the block languages are great for kind of end user programming and learning about thinking algorithmically, and maybe there's business applications for them. The other things aren't my field. I'm not really qualified to say whether or not, but like, yeah, if I design a programming language tomorrow, it's going to be a bunch of source files. It integrates well with Git.
Yes.
And we've got this huge amount of code review infrastructure. There's an install base of programs as files, and I think the programs as files install base requires programs as readable text, like you cat or diff it. It should do something reasonably sensible. So I think the code as binary AST community has a lot of very interesting ideas, but I don't think they're building on kind of these large investments in tooling.
There's something to be said about a hybrid where you're able to say let like logo equal an image, and which is still like mostly textual, but like also has a representation.
I think being able to having references be live, I think there's maybe a hybrid approach, like my comments are marked down and I can embed images in them, and when I'm viewing it in an editor, I get to see my dot diagrams which help me understand what the algorithm is doing, and things like that. Kind of I can refer in code to other things which are kind of more live than just text. And that's separable from the actual code parts. Are they represented as ASTs in some binary format, or are they
like actually
something that are they textual code like things that a programmer could look at with less and cat and other tools that are not aware of the language?
Strings attached or no strings attached?
So I guess what is that?
Interpret that any which way.
So I guess I mean, I guess I've been saying that I think when you're designing large systems, like distributed systems, you have to take strings in, you have to put strings out, because that's how we send network messages. But you want most of your intervening code, your domain objects, to not be represented as strings. And so you get away from strings as soon as possible, and you get back to strings as late as possible. So I think I'm going to go with strings unattached there. And then another possible interpretation, Python's repr, like Python's repr operator is supposed to take an object and turn it back into something that looks like Python code. In practice, it's almost never anything that you could actually drop into a command line prompt for something non-trivial and get it back. And so try creating your programming language so that it's attached, to the string representation. I think it's hard to get right. Yes, at the end of the day, objects are just more complicated than strings.
Yeah, I think that's.
So I'm going to say no. Even
no,
though,
it is.
yeah, like that's a decisive no to a question that I don't understand.
I love it.
Right.
This was a great chat, Mike. Thanks for chatting with me. Thank you all for listening. I'm Jas.
I'm Mike.
Thank you, Mike. If you like this, we're going to have episodes every couple of weeks. We'd love your feedback too. I suspect that given today's conversation, next time we might end up chatting about C and C-like languages, or maybe control flow. I think that both of those are interesting topics. It's been wonderful having you all.
Yeah, feel free to suggest topics you want to hear about.
Sounds great.
And not knowing about them hasn't stopped us yet.
Catch you another time. Thank you very much.